Hello everyone, I'm going to show you a near real-time ecological forecasting system that can link models with individual experiments, EcoPAD. This project has been going on for multiple years, and many of our lab members have worked on this project. Here is a list of EcoPAD team members and its collaborators. EcoPAD is short for the Ecological Platform for Assimilation of Data. It makes ecological forecast by bringing in the new observation data every week into the data simulation framework and then update model projections. You may wonder, why do we need ecological forecasting systems like EcoPAD? There is a fast-growing number of observation data diversity, both at finer, spatial, and temporal resolutions. Data assimilation helps make use of these data to understand the ecosystem behaviors. Ecological forecasting helps timely update model states and parameters, making the best projection based on the latest and greatest observations we retrieve. It is also beneficial for field observation activities. When we take measurement in the field, there is usually a time lag between data recorded and data quality check. Even though some data can be timely evaluated, there could always be some data points that is either too high or too low that we find it hard to explain if it is from measurement errors or it reflects the true reality. For example, the gross primary production, soil moisture, and net ecosystem carbon exchange. When we finally find a problem with measurement procedure or machine error, you could have lost quite an amount of valuable data, generating big data gaps. This situation, however, could be different if we have the one-week ecological forecast in hand. By comparing the two datasets, we could figure out if the spike in methane emission is an expected ecosystem behavior or a failure of measurement. We could take actions in time to correct it and make sure we collect data with high quality. EcoPAD can forecast ecosystem behavior 1 week ahead, driven by the 1 week forecasted meteorological data. Although all the models are built for offer projections, simple or complex, global or site scale. EcoPAD train and update model parameters every week with the new added observations. This whole process is automatically done and archived in a cyber infrastructure system and visible online. On the longer term, EcoPAD can analyze ecosystem behavior and responses to the climate change. For example, phase-dependent thermal acclimation or elevated CO2 fertilization. Now let's dive into some details. There are 3 elements needed within an ecological forecasting system. I'll go through them one by one. The first component is a process-based model that can quantitatively describe the real-world processes. Shown in this figure is a diagram of CLM 5.0. Any carbon cycle model can be plugged into EcoPAD. The first process-based model we used in EcoPAD is TICO. We're now working on incorporating ELM into the EcoPAD. For land carbon cycle, the complicated biogeochemical processes with not yet well described mechanisms and unconstrained parameters are the major sources of uncertainty. So, the second component is the data assimilation framework to optimize parameters. Without the data assimilation framework, we're using prior range of parameter values to generate forecasts of carbon pools and fluxes. we get a relatively big uncertainty range shown in the upper panel. But if we put the observation data into the data assimilation framework, we use the data-constrained posterior distribution to generate forecast. The uncertainty range will be largely reduced, shown in the lower panel.
The third component is the cyber infrastructure system designed to streamline web request response, data collection, modeling, validation, data simulation, near real-time forecast, and visualization. This system could timely optimize the parameter value by incorporating continuously updated observations from the field, just the same way as weather forecast. The cyber infrastructure include the web API to deliver data or request to a wide variety of applications. A RabbitMQ software is used to manage message. MongoDB is used to manage and automatically query or fetch diverse data streams. Celery is used to distribute work across working units. Docker is easily portable and scalable among different operation systems and was used to connect all the components within the EcoPAD. We see three parts all together. Here is how EcoPAD works for ecological forecasting in carbon cycle. If you are familiar with how weather forecast works, it is basically the same theory. Here is an example how we make leaf carbon pool forecast in the EcoPAD. In the beginning of the previous week, we make a projection of leaf carbon pool size using the process-based land model shown in yellow based on the past information. As new dataset being collected from the field in the upcoming week, we timely assimilate the observation data into the model and correct the projection shown in the blue area. The overlapping green area indicate the improvement of the model by timely using the new dataset to constrain the model. EcoPAD can predict how ecosystems respond to treatment on both short and long terms. It could also inform the experimenters which datasets are important to collect in order to understand the ecosystem and improve model performance. This model experiment system offers a platform for intensive communications between modelers and experimenters. In this way, both models and measurements will be improved. In today's practice session, you will be exploring EcoPAD online with Jiang and then design your own model simulation experiment. Okay, to sum up, EcoPAD is a web-based software designed to facilitate feasible and seamless model experiment communications. Both pool and flux-based data are used to reduce uncertainty. It automatically transfers and processes data from sensor network in the field on a weekly basis and recursively assimilate updated environmental and observational variables into the model and improve model prediction week by week. Experimenters and general public have easy access into model simulation, data simulation, and forecasting. It is also flexible for users who have higher demands. For example, those who want to test alternative data model fusion methods, use a different ecosystem model, or change the number of parameters to be constrained, or even change the observational variables that want to be used in the data model fusion framework. Here's a reference list where we show how this framework could be used for various research purposes.